Hello friends, welcome back to tutorial. In this tutorial we will study how we can convert a Mealy machine to Moore machine. That is, we will learn to construct a Moore machine equivalent to a given Mealy machine. As we know that in Mealy machine outputs are associated with transitions, and in Moore machine outputs are associated with states. So what we have to do when we have to transform a Mealy machine to Moore machine, then we will have to transform each state of Mealy machine into a state of Moore machine. Now look at this state Q1. It is a state of Mealy machine. Here outputs are associated with transitions. They are labeled on edges. Now what we have to do, we have to associate output with states if we want to transform into a state of Moore machine. So what will I do? Look at the incoming edges, right? Here incoming edges of state Q1 are labeled by output symbol 0. So what will I do? I will remove these output symbols from incoming edges and I will label the state with output symbol. Here these both edges are labeled by output symbol 0. So what I have done, I have removed that output symbol from incoming edges and associated it with state and leave outgoing edge as it is, right? Now it is a second case. Here the Q1 state has 3 incoming edges, right? 2 of them are labeled by output symbol 0 and 1 of them is labeled by output symbol 1. So here different incoming edges are labeled by different output symbols. So in this case what I can do, I will make 2 copies of Q1 state. When I will transform into a state of Moore machine, I will make 2 copies of Q1 state, right? With one I will associate output symbol 0 and with other one I will associate output symbol 1, right? So those incoming edges which are labeled by output symbol 0 will fall on this state, and those edges which are labeled by output symbol 1 will fall on this state. Outgoing edges will remain same. Now these two states have different incoming edges, but their outgoing edges are same, right? Suppose we are going to transform a Mealy machine to Moore machine, right? And its initial state has incoming edges which are labeled by different output symbols. Then what will we do? We will make 2 copies of initial state, right? When we transform into Moore machine, we will make 2 copies of initial state and select one of them to make initial state of Moore machine. Now third case. Now look at this state Q1. It has an incoming edge which is labeled by output symbol 0 and there is a loop which is labeled by output symbol 1. Now this loop is an incoming edge as well as an outgoing edge, right? So we can say it has 2 incoming edges. One is labeled by output symbol 0 and other is labeled by output symbol 1. So when we will transform it into a state of Moore machine, what will we do? We will make 2 copies of this state. With one we will associate output symbol 0 and with other one we will associate output symbol 1. Now see the incoming edge which is labeled by output symbol 0 will fall on that state which is associated with output symbol 0, right? Now the Q1 state has two incoming edges. One is labeled by input symbol A, other is labeled by input symbol B. So now this incoming edge, which is a loop, is associated with output symbol 1. So that edge will fall on this state, which is associated with output symbol 1. Now, as I told, outgoing edges will remain as it is. So this state Q1 has two outgoing edges also. One is this one, which falls on state Q3, and other is a loop. So these two states, Q11 and Q12, will have two outgoing edges, right? One falls on state Q3, right? From this state also there is an outgoing edge to Q3, and from this state also there is an outgoing edge Q3. And there is also one outgoing edge which is a loop. It falls on Q1 state. Now this edge will fall on that version of Q1 state which is associated with output symbol 1. So from here there is an outgoing edge to this state labeled by input symbol B, right? And from this state also there is an outgoing edge to the same state which is labeled by output symbol 1. Now it will be more clear when we convert this Mealy machine into Moore machine. Now look at this initial state, right? It has two incoming edges. One is from state Q3 and other is from state Q1. Both are labeled by different output symbols. So when we convert it into Moore machine, what we have to do, we will make two versions of this state. Here I have made two versions of this state and select any one of them as the initial state of Moore machine. One is associated with output symbol 0 and other is associated with output symbol 1, right? So from here, from Q3 state, there is an edge to Q0 state labeled by output symbol 1. So in this machine, right, which I have transformed, so from here there is a transition from Q3 state to that version of Q0 state which is associated with output symbol 1. From Q1 there is a transition to Q0 state which is labeled by output symbol 0. So here from Q1 there is a transition to that version of Q0 state which is associated with output symbol 0. Outgoing edges will remain as it is. From Q0 there is an outgoing edge to Q2 and one edge is to Q3. So both states, both new versions of Q0 will have these two outgoing edges. Now look at this machine. We have to transform other states also. Now Q1 and Q3 state. Q1 has two incoming edges. Both are labeled by output symbol 1. Q3 also has two incoming edges which are labeled by output symbol 0. So what will we do? We will remove output symbol from incoming edges and associate it with the state. So see their incoming edges here. These two incoming, one is the loop and one is from state Q2. We have removed output symbols from these incoming edges and associated it with the state Q1. And here in Q3 also, these incoming edges, right? both from these states Q0 to these are the two versions of Q0. So from these incoming edges we have removed output symbol and associated it with state Q3. Now only one state is left, that is Q2. Now we have to transform this state. So here we have made two versions of this state Q2. One is associated with output symbol 0 and other is associated with output symbol 1. So those incoming edges which are labeled by output symbol 0 will fall on this state, and those incoming edges which are labeled by output symbol 1 will fall on this state, and outgoing edges will remain as it is. Now see these two edges. These are incoming edges of state Q2 and are labeled by output symbol 1. So these edges will fall on this state. So what will we do? We will remove output symbol from incoming edges and associate. I have already associated it with the state. So they will be labeled only by input symbol. Now see the incoming edges which are labeled by output symbol 0. They will fall on this state. So one of them is this, which is from state Q3. It is labeled by input symbol A, and other is from state Q2 itself. Right? There's this edge, or we can say loop, from Q2 state is labeled by output symbol 0. So there must be an edge from Q2 state to this state, which is associated with output symbol 0. Now see its outgoing edge. It has only one outgoing edge, that is to state Q1. Both new versions of state Q2 will have same outgoing edges. Right? Now this machine is a Moore machine, which is equivalent to this Mealy machine. Right?